grade it yesterday because of Pi Day. So here we go. On number 10, even though it looks super nasty, at the end of the day, you guys knew what you were supposed to get. You were supposed to get identities, and you should have if you did it well, if you did it correctly. So number 10, the answer is yes. They are inverses. Why are they inverses? Because when you multiply, you get the identity. Number 18 was using that process or that method of doubly augmenting. And then row-reduced echelon form, row-reducing each of the different elements in order to get to the identity. And when you did row-reduce properly, you should have gotten the inverse of 1, 1, 3, 4. 1, 1, 3, 4. Could you have double-checked with the formula? Yeah. Could you have double-checked with your calculator? Yeah. But you were supposed to solve both 18 and 20 with the doubly augmented matrix. So number 20, the only difference is you had a 3 by 3. Once again, your row operation should have led you straight to the inverse. Does anybody remember 2 days ago in class, why did I, in a sense, defend showing you this way if at the end of the day, what I told you guys, all you needed to know from section 8.3 was how to do a 2 by 2 by hand with the formula. Why did I show you this way? Do you remember? And why did I give you homework and expect you to do it this way? A, does the formula work on a 3 by 3? The formula doesn't work on a 3 by 3. The formula only works on a 2 by 2. Where remember, we flip the main and we switch the signs of the opposite 1 over the determinant. That formula only works for 2 by 2. So first of all, that wouldn't work. You couldn't do it by hand at all with a 3 by 3. But number 2, what am I forcing you to practice? Row reducing. And isn't that what we took a long time in 8.1, studying, practicing, making sure that you could do? Does that make sense? Okay, so you're practicing it, which is a good thing, because that means you're not losing the skills from 8.1 so that you still have it for the test. So not only is it a possible way to do a 3 by 3 by hand, and the formula is not, but also it's making you practice 8.1 some more. So anybody that shortcutted that practice, well, you just lost an opportunity to be more prepared for your test. Chris?
What if you did the adding the 2 columns, or the 2 columns?
That's determinants.
Same thing, and then you checked it. Does it work out? Like, does it still have the same answer?
Just by finding the determinant? This is an inverse. It's not a determinant, though. The determinant is a number. The determinant is a number. So what did you do? You did 1 over the determinant of the 3 by 3, and then you did the main. You flipped all of these? How did you flip all of these?
Oh, no, I didn't. No. I multiplied 1 by 7 by negative 7, 2 by 9 by negative 1, 2 times 3.
Yeah, I got that you got the determinant, and that's a number. So determinant of A is equal, and you got a number. But the problem is you were supposed to get the inverse matrix. So my question is how you got that.
No, I'm starting to think about it. I got it.
You got this?
Yeah, I have, negative 13, 16.
Okay, so what'd you get as your determinant?
I don't know. I think I don't know.
Okay. So if you did the main 1, 7, negative 7, that would be negative 49. And then if you did the next one, it would be 2 times 9 times negative 1, so that'd be negative 18. And if you did the next one, that'd be 2 times 3 times negative 4, that'd be negative 24. Minus the opposites. Okay, struggle. You would have 2 times 3 times negative 7, 6, negative 42. And this is technically section 8.4 that you're doing right now, right? Then if you came back, you would have 1 and 9 and negative 4, which would be negative 36. And then if you went back, you'd have 2 and 7 and negative 1, which would be negative 14. So I get what you mean when you said you did main, opposite, opposite, opposite. You were finding the determinant of A, which is a value, which is a number. You weren't able to give it to me, so I'm just trying to do it. That'd be 30, 42, that'd be 62, 71, negative 71, minus. And then you would have 40, 50, 92. And so minus a negative 92, that would be 9, is that 21? Yeah, positive 21. I just don't know how 21 would help you find the inverse. Now we do have that formula for a 2 by 2 that says you do 1 over the determinant, which would be 1 over 21. So all I can think about as to what you might have tried is flipping the main and switching the signs of the opposite. But the problem is, number one, that doesn't touch on any of these because they're not in the main or the opposite. And I'm not sure how you would flip 3. When we had 2, we just switched places. But when we have 3, do we switch, switch? Do we switch, switch? Do we? I'm not sure what you would have done.
I don't know how I got to the answer.
Okay, it might have been a little bit magical. So try to see if you can figure it out. I get that you can find the determinant, and I totally agree. That was all of section 8.4. I'm just not sure how you would have used the formula. So keep pondering, Chris. If you can figure it out, let me know, because I'm super curious. But for right now, I just don't see how that's valid. Jackie.
I got the same answer, but I think I just used my calculator with the inverse.
Oh, okay.
But I'm pretty sure you probably want us to write it out.
Right, because you were supposed to do it with a doubly augmented matrix. I guess you could have written this in your calculator and done RREF. Once again, you're kind of cheating yourself out of a chance to practice. So you could have done RREF with this, and the calculator would have done all this work for you. Of course, you could have used the inverse button, and I said on a test, that's all you're going to need to be able to do for a 3 by 3 or above. But remember, I was explaining you were supposed to do this by hand as I modeled in class to practice 8.1 and to see how you could do it by hand. But that's right. Jackie is saying, Chris, that you might have just used the inverse button in your calculator and thought that they kind of worked, and maybe, I don't know, keep thinking. Number 40, it was just determinant. Main minus opposite. Your final answer would have been negative 143 over 36. And once you found the determinant, you could have plugged into your formula. 1 over the determinant would have flipped it, and when you would have gone ahead and multiplied, it would have been nasty, but you would have had the proper inverse, which is right there. Number 50 is a little bit easier as far as no fractions, but still the same process. Main minus opposite is your determinant, AD minus BC. 1 over that times flipping the main, switching the signs of the opposite would have gotten you your final determinant. Your final inverse of, did they not solve for it? Here's their inverse. They were just multiplying their inverse by the constants. This is one of those solving the equation ones. Your final solution would have been 1/2 and 1/3. I wish they had shown this a little bit clearer. They're being a little bit messy. There's their inverse, and then they multiplied it by the constants. That was like an application that we saw towards the end of notes. Final answer, 1/2, 1/3. And then that's the end. Let me leave it on number 50 for a second. Do you guys have any questions on the odds? Let's start with the odds, because you could have checked them and calc chatted them. Jacob. Okay, Jackie.
I actually have a question on 50 because
Okay.
I got the same answer, but I just kind of put it back. I can show you.
Let me pull up the question real quick, because there are many ways to solve 50, including just system of equations. They were just asking you to try to use the inverse matrix to solve. So guys, checking out number 50, could you have done substitution? The answer is yes. Could you have done elimination? The answer is yes. Could you have made this into a matrix and done RREF? Yes. All of those are ways to solve that problem if there weren't these directions. The struggle is the directions say use an inverse matrix. So to use an inverse matrix, you would have done the process of, they didn't show this in the, bless you, in the problem itself, but you would have done the process of, let me try to remember what's going on. Splitting up your constants with your variables. And what the process says to solve for an inverse is if you have a times x equaling b, if you can just find the inverse and multiply, then that will cancel out and you'll have x equals the inverse times b. So what they did is they said, cool, I can find an inverse, and they did. And what they do with that inverse, they multiplied it by b. So they found the inverse, they multiplied it by b, and that was a way to solve for x. It's a way. Not the only way, but it's a way. Using the inverse like the directions ask. Okay, questions on evens, I guess now. Or AJ Silvanad, go ahead. 71. And then Jacob, what was your question? Okay. Let me peek at 18 first because it comes first, AJ. 71. So number 18. I think you were supposed to be finding the inverse. Is that right, Jacob? Okay. So for finding the inverse, remember our formula. You guys tell me. Because this formula is something that you were doing really well in class. I know we had Pi Day, but you were supposed to practice in homework. Formula says to find the inverse, 1 over AD minus BC. So 4 minus 3 would be 1. And then what do we do to the main? Flip it. So that'd be 1 and 4. What do we do the opposite? Change the signs. The nice thing is when you did AD minus BC and got 4 minus 3, that made it all nice and easy because then it just stayed the same. If it was like a half, you could either leave it outside, kind of like they did in that nasty one for number 50, or you technically, in order to finish, would need to distribute it like you would with any constant. Does that make sense? Okay. And then 71, AJ had a question on. A florist is creating 10 centerpieces for the tables at wedding reception. Roses cost $250, lilies cost $4 each, irises cost $2 each. Customer has a budget of $300 allocated for the 12 centerpieces, or no, for the 10 centerpieces, and wants each centerpiece to contain 12 flowers with twice as many roses as the number of the lilies and irises combined. Okay, so they need us to write some equations for it, yeah? I'm going to go ahead and real quick dual screen so that this is a little bit easier for us to see. Let me throw this over here. Let me throw this over here. And there we go. Okay. What do you guys see as far as like some sort of relationship that we need to, because linear combinations or linear equations just say, hey, what are relationships? So what do I got? I think I see money. Yeah, do you guys see money first? Okay. So I see roses being, we'll make this the rose column if that helps. Roses I know need to be $250. Lilies are going to be $4 each. Irises, $2 each. And how much total money does she have? Okay. So then if we were doing a system of equations, we call roses X, lilies Y, irises Z, add them all up. She only has $300. But what else do you see besides money? She wants 10 total centerpieces with 12 flowers each. Okay. So I need X plus Y plus Z to equal 120. I think that's the easiest way to do that. Because 10 centerpieces with 12 flowers each, I need as many, or how many roses, how many lilies, how many irises, I need 120. Now, any florist would buy way more than this, but it's okay. Because some flowers come and they're bruised and they're broken. But anyway, long story short, I've done too many weddings. X plus Y plus Z, all the flowers need to equal 120. We're just saying that they're getting the bare minimum. But what do they also say? There's one more clue. Okay. So the number of roses needs to be, right? Number of roses is 2 times as many as irises plus lilies. Does that make sense? But hold on. Wait. You see how nice this has been, right? Do I really want it written like that? No. So I'm going to go ahead and rearrange this. Can't I make it 2y and 2z? And can't I subtract that to that side to get it all nice? And so I'm going to end up actually with, after rearranging, if I can get that to be gone, x minus 2y minus 2z equals 0. There's my system. 1 and 2 and 3. Then it says write a matrix equation that corresponds to your system. You guys know how to do that, right? Pull out the coefficients, make a matrix. Then it says to solve your system using an inverse matrix. At this point, kiddos, since this is in the word problem section, this would be a calculator problem. So what you could do is you could say, hey, how many for my x and my y and my z is going to end up equaling A inverse, which you could do in your calculator, times 300, 120. And this is using the exact same idea as the question that Jackie was asking about. You can find your variable by taking the inverse of this matrix, which, how do we do that in our calculator? The little -1 button, right? So you could throw 2.542, 1, 1, 1, 1, -2, -2. We could throw that in as A, and then just do A inverse times 300, 120, 0. We'll be done with how many x's, how many y's, and how many z's. AJ, that help out? Good. All right, cool kids. This is on the video if you need a little more time with it. Before you pack up your spirals, though, go ahead and keep your spirals open to the first page of your 8.3 work. We were going to grade 8.4, but because of the questions and because we don't have anything to specifically grade tomorrow, we'll grade 8.4 tomorrow and give some of you that needed a little extra time on that one a little extra time. But 8.3 was due yesterday. You had another day of grace. So as you guys start taking notes, I'm going to spot check 8.3. Homework spirals, just keep them open. Have them on your desk with your grading showing. And you guys are starting notes on 8.5. What homework is this? Homework 49. Is this homework 49, Jackie?
Oh, I don't
Oh.
I think it's 49.
What homework number was it? 51? Okay. Okay. Guys, are my homework numbers off? Should 8.5 be 53? Because 8.3 is 51? Okay. So 8.4 should be 52 and 8.5 should be 53? Okay. Okay. Jackie, check. As soon as I say your name, you can go ahead and put it away. Oh, you're 50. See, you're like I was. Huh. Okay. Hold on, our homework numbers are all kind of messed up. Let me freeze the screen real fast and see what it says online. Because Noah and I have one thing, and some of you guys have a very different thing. What's going on? Precalc. Homework sheets. $49, $50, $51. What were the homeworks for Chapter 7? Did my numbering get off?
It's because we skipped to the section of chapter 7.
Oh, we skipped a section, so you won't see it in your... Yeah, we skipped 7-6, didn't we? 47. Huh, but even still, 47, that's the one we skipped. This should be 48, huh? There's a magical missing 48. All right. I'm going to change the numbering real fast. I don't know what happened. Sorry, guys. That's really weird. Okay. So then 8.3 will be homework 50. 51 is 8.4. 52 is 8.3. 51, 52. Okay, if you guys want to fix your numbering, sorry. We are going to have a missing 47 because we ended up skipping section 7.6, but still my numbering had a magical 48 that was never used, so I apologize for that. All right, let's get back to our notes so that you guys can be copying. There we go. But now we're all on the same page, hopefully. All right, but no, I got you. Good, thank you. Lainey? Good, I got you. Jaden? Good, just have a couple more to do. Yeah. Ooh, we're checking 8.3 right now, bud, the one we were grading today? Or 8.2? And you're supposed to be done with 8.4? All right, so what's your job for this week and this weekend? To get caught up. Hey guys, when was 8.3 due again? Yesterday. Okay, just checking. P.S. I'm spot checking 8.4, but I'm spot checking your homework spirals up through 8.4 tomorrow. It's going to be worth 10 points. Oh, because you're not supposed to throw in the extras. You need to make it a 3x3. You're just doing the coefficients. Because you can't have an inverse if it's not square. So then go ahead and run. And what you're going to do is you're going to take that A inverse and multiply it by. And then throw in your answers, and then multiply the two. Does that make sense? Which it should end up being the same as RREF of your 3x4. Chris, I got you. Okay, we're on 8.3, bud. Actually, technically, we're on 8.4. Vicky. Okay. Yeah. To be your determinant. You flip those, and then you opposite those. Yes. Good, good, good. Kiri? Okay. But you'll show me a colored pen later? Okay. Yeah, you can use the video to get the colored pen down. That's okay. I'm just grading 8.3. Good, Ryan. Wow, we have a group. The entire group did it. Go team. Yeah. Joyce, I got you. Because you're probably doing kind of what AJ did with this one. You're used from section 8.1 to be putting in the whole thing. But that's not what you're doing. What you're doing is making this guy A, just him. Oh, wait. I didn't see that you... Good thing you didn't finish by hand, because that would have been a lot of work. You're taking him, making him A. You're making him B. So that's going to be your B, that's going to be your A. Then in your calculator, you're putting A inverse times B. Then what you get should be how many roses, how many lilies, I think was next. And then how many, Z might be backwards, sorry. How many irises last? Does that make sense? 8.3. Good. Chris. And then Michael's absent today? Yeah. So what did I say tomorrow? I'm spot checking what? That's due today. Spot checking 8.4, and you have to have your spiral totally up to date for chapter 8 in order to get the full 10 points for the spot check on 1 homework. Sound good? It doesn't sound good, but you understand? Okay. Section 8.5. Applications of matrices and determinants. I need to tell you guys something from the get-go on this. The application section, you can use your calculator the whole time. Okay? The application section, you can use your calculator the whole time, which is really nice and really good. But even though you can use your calculator the whole time, you need to know how to use it. Okay? You need to know how to use it. If I was to ask you to do Kramer's rule, kind of like Jackie said in that homework problem in 8.3, there are lots of ways to solve this system. Okay? There are lots of ways to solve this system. But if I ask, for instance, on a test to show me Kramer's rule, you would need to show me how to get here, and then you could use your calculator to finish it. You wouldn't have to solve by hand. But you would need to at least show me what or how to use Kramer's rule, and then you could use your calculator to solve it. And here's how you use Kramer's rule, or here's how to do Kramer's rule. Once again, it's easier on the easiest types of problems. This entire section just says, hey, what are some uses for determinants? Kind of like dot products and vectors, like I said yesterday. Determinants and matrices. Determinants have lots of different uses. Here's just a few. For Kramer's rule, what on earth is going on? So we have two different unknowns, x and y. If it was bigger, it'd be x and y and z. X and y and z and w, or whatever. You have different variables, x and y. In order to solve them, if you notice, both of them are fractions. Both of them have numerators and denominators. And in those numerators and denominators, you guys have two different sets of matrices. This bottom is what we're going to call the determinant